Welcome back to our Breakout Labs. This is Breakout Lab 3. We are going to jump right in here. We're going to start with a process that we'll normally go through for these labs going forward. We'll start by going into a file explorer and going to our documents and then repositories. And we want to always make sure this repository is up to date, so the fgcugl. So I'm going to go in there, and it's a Git repository, so you should have Git installed. And then I'm going to go in here and open this Git Bash, which is just a terminal window, and it just makes this simple. So now that I'm in this folder, the repos fgcugl, I can just do a git pull. Alright, and it says it's updating. Now, it's only updated my fgcugl CPP file, but yours probably going to update both of them. I've been doing some testing with this. Alright, but now that we're up to date with the files, I can close this. And I am going to start up Visual Studio. I'll just leave this open. I'm going to start up Visual Studio. And I'm going to start with creating a new project. And I'm going to use my Breakout template. If you don't see it here, you may have to scroll to the bottom here to find it. It doesn't matter which place you select it from. And I'm going to say next. And then this will be Breakout 3. And it's in my document repositories. Place in the same folder the solution in the project. All right, we have Visual Studio open, and here's my source files and my header files. All right, so I'm going to open up my Breakout CPP file. All right, and so what we have our file header comment block. Yours should be filled out. And we have our IOStream library for debugging, and then we have our fgcugl library is our OpenGL library. We have some constants for setting up the window, the width and height, and the title. I'm going to go ahead and change these now and make this 800 by 600 pixels with the title Breakout. We have our int main, and this, and then here we have our OpenGL window to get a window open by the window width and height and the title. And then we have false here so that it's not resizable. Then we go into, this is going to be our main game loop. And that'll mean something to us later. And if I come down here to this ending curly brace, I can put end main game loop. I could even leave off main and just say, well, I'll leave that. I'll leave this up here. Okay, and then within this, while our window that we opened is not closing, we want to paint the window and look for events like the window closing or keyboard events, which is what we're going to be looking for tonight. And then once we do close out, we go through a cleanup routine and then return 0. All right, so let's get started. In the previous lab, lab 2, we were drawing circles on the screen. Today we want to draw some boxes. So let's see what we have. We want to do it before we call window paint. Let's see what we have in our library. fgcugl, our namespace operator, and then let's do draw, and here's all our draw functions. So we did draw a circle, we have line, point, and quad, and text. And we're going to want to do a quad. All right, so this will draw a four-sided block for us by the X and Y at that location. It says the X is the left and the Y is the bottom by width and height, and then color, and it's defaulted to white, right? And does not return anything. Okay, good. So let's do, I just double clicked it, and I'm going to do my parentheses for the parameter list, and then for arguments right now, let's center a square. So we can just calculate it in our head. Half of the width, half of 800 would be 400, and half of our 600 height would be 300 for the Y. And then so that we can see it real good, let's do 100 height width and 100 height. And we'll just leave the default color for now. All right, end it with a semicolon. All right, let's build. Okay, and then let's run it. All right, and here we go. We got our console terminal window back here where we can catch some debugging statements if we want, and then we have our breakout game window. Notice we can move it around, but we don't get this resize bars anymore. These things, the double arrows, we don't get that anymore. But here's our block, and if you look at this kind of carefully, you can kind of picture that the middle of the screen is right along that left edge. And the middle of the screen vertically is right along that bottom edge. So this square is actually in the top right quadrant of this screen, right? And so what we see is our X and Y put us at this bottom point at the center of the screen. So X came over widthwise and Y came up from the bottom. So for us to really center this block, we would have to subtract half its width to go back to the left. And we'd have to subtract half its height to come back down. So let's do that. I'm going to hit stop because for some reason on Windows right now, it's not catching that window close event like it does. It is doing it on Linux, but the Windows isn't doing it. I'll fix that later. All right, so let's go ahead and set up some variables for doing this. All right, and I'm just going to do it in the order we see here. So this was the width, height, the X position, the Y position, the width, and the height. So if we start setting those up, we're going to just stay with floats. And we'll talk about that in a second. But let's do a block X at, let's go ahead and do our window width divided by 2. And then float block Y at window height divided by 2, right? And then we can do a float block width, and right now we just have that at 100 and a block. Not a flock, but a block height at 100. And let's be good and do float literals since we're doing floating point numbers here. Notice our window width and height are integers, but we can just use the float literals here to help force the float division to happen. All right, and then let's start replacing those in here. So our block X goes where the 400 is, block Y where the 300 is, and then our block width and our block height. All right, so nothing should have changed. Let's build. We should still be centering that bottom left corner. All right, so it looks like that bottom left corner is still at the center point. All right, so now we need to do our math. All right, so if we come down here and we start doing, well, we want to subtract half of the block's width from the block X. So if we start doing minus block width divided by 2. All right, notice that's gone red. All right, why is that gone red? I mean, all these variables are inside this scope, right? So remember, variable declarations happen at build time, not at run time. So every time we come around this loop, we're not redeclaring block X, all right? The build process set up the assembly statements that would allocate these memory blocks and not really so much as allocate them as set up the references to each of the memory blocks addresses. All right, and that's only done once as part of the loading of the program. All right, it's only the assignment that's happening every loop. And as far as the build process is concerned, it doesn't know about this variable yet. It hasn't seen a declaration for it in the build. So we have to declare these before we can use them. So if we just put them above, now all of a sudden it can see it. So it's just something to keep in mind when you're putting your program together. You may have to move things around as you add more things. All right, so we want to subtract from the center position of the screen half the block's width, and subtract from the center vertical position half the block's height. And remember, we don't need parentheses around here because the operator order of precedence, the divisions will happen first. Oh, we should be doing floating point division though. All right, so the divisions will happen first and then the subtractions. All right, let's make sure this is all still working. All right, we got a build. All right, and now this block looks more centered in the screen. So our center position of our screen is now somewhere right in here in the center of the block. All right, so I'm just gonna stop the debugger. And we notice we're doing floats now, right? But we don't have fractional pixel positions on our screen. All of our pixels are at whole integer positions. And that's okay. Our drawing functions will handle truncating any floating point decimals from the positions when it goes to paint, draw on the screen. And that's okay. We don't have to worry about that. We want to keep this floating point math though, because we're going to be doing some calculations later where we need to hold on to those fractional pieces. We'll see that when we get into the moving objects and stuff, which we're going to do today. So let's get started on that. So one thing is, like we said, the declaration of these variables only happens once at build time. These assignments are happening every time this loop runs. So every time this loop comes back around, we're resetting our block, this memory block to 100 and this memory block to 100, and resetting this one to the center of the screen and this one to the center vertical of the screen, center horizontal, right? So even if we were to change the X and Y of the block here, next loop we'd reset it. And so we would actually never really see it move because it would keep jumping right back to where it was. So we need to move these out of the while loop, right? And just like being able to see the declaration of this before we do this, we have to move these before the while loop so that they were defined and initialized before we try to use them. So let's go ahead and move these now. All right. And let's start adding some commenting here. All right, we can do the OpenGL window first. I'm just gonna, and then here we can say, well, draw a block. I'm going to do it after this. Right? That's kind of self-explanatory. Block width, block height. But let's draw a block in the center of the screen. All right. So this is those functional comments that I've been talking about, where it doesn't really explain how specifically this works. I can read it, right? Window width divided by 2 minus block width divided by 2. But it tells me what to expect. So draw a block in the center of the screen. Now when I see this, I can go, oh, I see it. Okay, window width divided by 2 minus the width of the block divided by 2. All right, so now it makes sense what this logic is down here. We don't want to explain the how. That's what the C++ and the good variable naming does for us. I know I'm setting the block X position and the block Y. So that is self-explanatory, but this helps me understand very quickly why this formula is here, and I can interpret the formula faster. All right, enough said there. So now Now we'll just be redrawing that block in the center of the screen every time. So nothing should have changed if I run it real quick. And it's every time you move things, if it's still in a runnable state, it's good to check and just make sure you didn't mess something up. Okay, now we want to start moving stuff. So to move stuff, first we need to be able to tell it we want it to move. And so we're looking for some keyboard input. So one of the easy things to do here is let's just see what's in our library. So fgcugl, our namespace operator, and let's do get. What can we get? We can get events, which we're already doing. We said that has to be done at the bottom of our loop every time. We have get key, and that looks promising. And then we have get time. So let's look at this get key. It says that it's going to return an unsigned character, right? That's its return type. The return is an ASCII2 character code for a key pressed. It can only return one key code. In other words, if somebody's holding down more than one key, only one value is going to get returned. And it gives us an order of precedence: the escape key, the X key, WSAD. And then if you're using the arrows, up, down, left, or right arrow keys, it will return WSAD or none. And if we look down in the returns, we see unsigned character, ASCII2 code, or 0 for null. So none is the 0. Okay, so let's do a get key, and we notice it doesn't take any, it has no parameters, so it doesn't take any arguments. So we just have to do an empty parameter or argument list. All right, but it returns a character code, an unsigned character, it said, right? And if it returns it to the left. So we need an unsigned character over here. We need to give it a name. Let's just call it key. And then we must assign the return of get key to that variable. So we can do an assignment operator, all right? That should get us a key. Now, we're expecting WSAD for WASD for our up, down, left, and right. So we need to test for those. All right, so we're going to build an if statement. So we can do our if, right? That's our keyword. Now we need our conditional expression. So our parentheses set up our conditional expression, right? And then we can do, I'm going to do it this way, and then I'll set it up a different way as well. But we can test key. We want to know if this overwrote that memory, what is the current value of in that memory. So we can test what's in this memory, and we want to test that for equality to a character code like W. Now we don't know what the value of W is, but these single quotes tell the compiler to convert that to its ASCII2 number. And we're expecting key to have a number that might match that number. And our equality operator will return true if those two match, or false if they don't. Remember, don't ever do that. All right, we don't want to do that, because all we'd be doing is setting the memory block for key to the ASCII2 code of W every time. We don't want to do that. We want to test for it. All right, so if key equals W, we want to move up. And we said our Y is our vertical component. It starts at 0 at the bottom of our screen and increases as we move up. So we need to add. So let's add. Let's add to our block Y. Let's just add 2. And let's keep it as floating point. We'll add 2. And so we're doing the addition assignment operator to say add 2 to the current value of block Y, and save that in the memory block of block Y. Okay, now we could say, well, else if key equals S, we want to go down. And we could do block Y. So to go down, we have to subtract. So we're going to do a minus equals, and we'll do our floating point literal. Right, okay. So this would handle up and down. Let's see what happens. I'm going to build. going to run. All right, and I'm going to press the W key. Okay, now I pressed it really fast, like I tapped it. Notice it jumped well across the screen. All right, I can do the same thing with the arrow keys. Now if I hold it down, whoa, it's gone. If I do, oh, there we go. If I do it slowly up, you gotta tap it really fast. Right, it moves around pretty quick. Now later on, we're gonna be doing something to slow this down. So if you pressed and yours like disappeared, try just tapping really fast to get it to come back in the other direction. All right, so let's stop this. Okay, so as of right now, we just have W and S. So, but notice it's all crammed together. Now we can space it out like this, and that's nice, or we can space it out like this. And the more we start spacing it out, the more it gets hard to know what belongs to what. So let's just make an agreement that these curly braces make things look better. But remember, we didn't have to have them because we only had one execution statement after the block, after the conditional expression. And if we only have one executable instruction, we don't technically need the curly braces. But the curly braces help. One, it helps build some space. And yes, you can do the Java version. You can do it like this. That's fine. No worries here, as long as you keep it neat. I'd rather you have some white space in there if you're going to do it. And that's kind of why I like using the old C style, because it kind of gives me that clean, spaced out. I can read it easily. I know where things go. All right. Another thing to remember, this whole thing is the if statement. It just has two true blocks in it right now. All right, so we need to add the other blocks, and I'm going to let you do that. In other words, add else if for A and D. This is lab 3.1. Something like that. I don't remember the numbering convention that I did before. So you need to add some else ifs. Now we don't have an else in here, do we? I mean, what if they did none? Well, we don't care, right? We don't care. We still want to draw the quad at whatever its previous position is. All right, we need to draw it every time. Otherwise it would disappear from our screen. So we don't have to have an else. If we have no reason to have an else, then we don't have to have it. But what else could we do? What if we wanted to resize the block? All right, right now we have W and S are increasing or decreasing the Y position. And so obviously the A and the D need to affect the block X. But what if somebody pressed the escape key? Let's use the escape key to toggle our mode so that we are either moving or resizing. All right, so let's set that up. Let's set up a mode. Let's do mode. Let's do a Boolean mode, or let's do move equals true. And we just use the true literal, okay? And then let's say if key equals, let's do the X key. So we only have a few keys that we handle, but I don't want to go into the escape key just yet. But let's just use the X key. That was one. If we scroll over get key, notice it handles escape, X, WSAD, or WSAD, or none. So let's use X. That'll be an easy one. And then let's do, okay, so I've added X, and I just want to change the mode. So I could say move becomes false, So I could say move equals not move, and that would make it false. All right, or basically I'm toggling it if they hit an X. All right, and then so now what I could do is I could do a nested if in here, and I could say if move, then I'm going to set block Y, I'm going to add to block Y, else I'm going to increase, this would be up, and we'll say up, I need to increase the block's height. So block height plus equals 2.0. All right, and if we do down, well, I can do the same thing. If move, I want to decrease the block's Y, else I want to decrease the block height, minus equals 2.0. All right, so let's see if this works. Now remember how fast our block moved when we hit W and S. Now we could be toggling with the X multiple times. So it's going to be hit or miss whether or not we get a real toggle. So here I'm doing my up and down. I am going to hit the X as fast as I can, and I'm still in move. And I'm still in move. Yep, I'm not getting it to resize. Not getting the toggle to work. Okay, yeah, so just slight mistake in here in that what I was saying before is holding true for our block X and Y. Because we declared our move here and set it to true in our loop, every time we come around the loop, we're resetting move to true, and we didn't. We want to start it at true, but then we wanted to toggle it in here. So let's move this and put it up here. And this is going to be toggle move or resize of block. All right, so let's just try it again real quick. I'm going to build, and then we'll talk a little bit about what we have code-wise. Okay, so now if I do the up arrow and down arrow, I'm moving the block. If I hit the X, oh, there we go. Now I'm in resize mode. If I hit the X again, oh, now I'm moving it. If I hit the X again, oh, still moving. Still moving. Oh, now I'm resizing again. Look at that, I can even go negative. How's that? All right, cool. So, what have we demonstrated with this so far? Well, right now, we would do add an else if for A and D, move and resize. So we need an else if for A and an else if for B, and then we need to handle the move, 3.11, and 3.1.2 resize. All right. Oop. And so we need the same thing here for this would be 3.2.1 and 3.2.2. So we need to do what we see here. We need to do for the A and the D for move and resize. All right, so this would be if moving, then move up. Else make block taller. This would be if moving, then move down. And this would be make block smaller. Okay, now obviously it flips and starts becoming taller. So instead of make block taller, it would be grow block upwards. Grow block upwards. And this would be grow block downwards. And moving is spelled wrong. All right, so what we'd be doing is duplicating this logic down here for the width and the x, or the x and the width. All right, and what are we doing here? Well, the first thing I want you to notice is we defined move as a Boolean, and we used our Boolean literal true to set it. In here, if our key is an x, we set our move equal to not move. So if move is currently true, we say make that false and store that in move. If it's false, make it true and store that. Then we go into this if statement. Now, here's the thing. This can only return one key. So if the key is x, can it be any of these? All right, the answer is no. So we could actually combine these two if statements so that if the key is x, we adjust the move and then we toggle the current state of our move variable and we skip the rest of this. All we have to do is make this an else if. And we have now made this one large if statement to include what you're going to add. All right, so that's something to think about as you're building if statements. If we only want a hierarchical one choice, then we want to use else if, so we jump all the way to the bottom. All right, now we don't have an else condition in this one because we don't have anything to do if it's not one of these keys. All right, now nested inside these ifs, we have another if statement, which is not part of this if statement at all. These are individual statements. And notice we're testing if move, but we didn't put like any kind of equality operator because if move is true, well, move is a Boolean value. It's either true or false. If it's true, then this condition is true and we go here. If it's not true, we go here. Same thing here. If the current value of move is true, we go to the true block, else we go to the false block. So this is what I said in class. When we have Booleans, variables, in conditional expressions, we don't typically ever have a relational comparison operator because the value is either true or false. Okay, so just make sure I didn't mess anything up. I'm going to run it one more time. When you're done, you should be able to go left, right, up, or down. Hit the X up. There we go. I got the toggle. I'm going to stop it. All right, and that's going to be it for this lab. There'll be another lab coming out where we're going to change some of this handling to use a switch statement. So I'll see you in the next lab. Go ahead and get lab 3 done. Add your horizontal handling, and I'll see you in the next lab.